Gentlemen,
What's up?
what's happening?
What's going on?
I'm good. I just had an energy drink, so I'm good.
Yeah.
Jeez, man.
Dude, you're just trying to make that heart explode, huh?
Whew. Yeah, I'm sweating. It's like 73 degrees in here.
All right. So
How can
for anybody
you
watching
sweat
the
at
show,
73 degrees?
That's what I'm saying.
How do you sweat?
because it ain't at 68 degrees. Everybody knows that. You know, you get further you go south, the more you just do 68.
I got that Florida blood, baby.
Florida blood. You should be like 73 is cold.
It is. I'm freezing normally.
Yeah.
But when I got that, what is
We've
it?
got that energy
that
drink running,
drink, that
you know,
bang,
B12, whatever else,
all the
you know,
cylinders are firing
steroids,
off. Boom.
maybe some crystal meth in there, you know, a little bit
Yeah,
of everything.
I don't know. We'll find out later in about 10 years if I make it there.
Yeah.
Golly, I'm sweating.
All right. For those who have never seen the show before, this is the HVAC Grapevine Show. I'm your host, Chris Hughes. To my right, Mr. Eric Kaiser. Below me, Mr. Michael Cianfrocco.
What's up?
We are scattered around the country to bring to you HVAC news.
But we're unified.
And other HVAC random stuff.
And yeah. And it's funny, we got somebody wrote on our YouTube channel the other day that they watched the 500 square foot per ton show. And they were like, man, this show started off great. And I was like, all right, thumbs up. And then he said, but then it kind of went totally off the rails. And I don't know if you guys finished off where it should have been. And I was like, yeah, that's how it goes.
Yeah, it's
So
not
it's like,
scripted.
you show up, you never know what you're going to get.
Did they watch part 2?
Oh, I don't know. It was just somebody commenting on our thread channel.
Yeah, we probably started talking about like barbecuing, you know.
Probably so. That was the show when we had Michael's guest on.
We should call this show just Off the Rails.
Yeah,
Maybe we should change the name.
the intro should be Ozzy Osbourne.
And then we confuse everybody. And then the 10 people we do have watching, it'll go down to like 3.
Mm-hmm.
And then before you know, it'll be nobody, and we'll just be talking to ourselves, which is what we do anyway.
I'm not here for the views. I'm just here to hang out with you guys.
That's right.
I mean,
I don't need money. I'm rich.
It's
why
just
we don't monetize.
Just 3 guys sitting around talking on a Sunday night about random HVAC stuff.
It's like coffee talk without the coffee and without the extra HVAC.
And plenty of steroid drinks.
Oh my God, yeah.
I got the coffee tonight.
Oh, look at you with the Christmas cup, man.
That's right, baby. Look at that. It's Christmas time.
Yeah.
It's getting close, man.
What's all up in that coffee? Is that like, Eric, I've been to your house. I know you guys, you and Rachel. Y'all always do everything special, bro. Like, what's up with that coffee? That's not probably regular coffee. I mean, did you grow those beans, grind them yourself? I know how y'all roll, man.
Yeah.
You guys like ferment those and I
went all the way. As I ran down to Menards, down the street to Menards earlier, I stopped by the Big B Coffee on my way home and picked that up. It's actually a mocha, but you know.
Oh, it's regular people stuff. All right.
I'm really surprised that y'all don't have like a cappuccino machine, you know, where like everything does it.
We're not big coffee drinkers.
Well, no kidding.
Like that's an occasional thing.
That's a big no for me. We're gonna have to change that, Eric.
Interesting.
I'm gonna have to buy you an espresso machine for Christmas.
Oh my gosh, no, we got enough kitchen gadgets already.
I figure these two had a pack of lemurs in the backyard. They were feeding, some. You ever hear about that? $500 a bag, man.
You're talking about you're talking about the civet cats.
Oh, see, he got me again. This
Not
is why we got Eric.
Civet cats.
Attention to the details.
So shout out to some of our boys in the chat tonight. We've got Ty Branneman. We've got Tom. We've got Doug, Michael, Dustin Cole.
Yeah.
What's up? A few of the
everybody?
regulars. All right. So our guest tonight is probably one of my funnest people to sit around and chat with. This is Eric's wife, Rachel. And before I bring her in, I just want to give her my best intro, right? Every time I talk to Rachel, I just feel a little bit more dumb about myself. About man, where did I go wrong in the educational part of life, right?
But you always learn something, so you walk away a little bit smarter.
Yeah,
Smarter
absolutely. Every time I talk to her, I walk away going, "Damn, is there anything that girl doesn't know?" Every time I see her, that's what I think.
I got to live with this all day long. How dumb do you think I feel?
She is, like Ty said, she is literally brilliant.
Yeah.
And so last show we were talking about metals, and I can't remember where we ended off with that.
Yeah. How did
and we were joking.
You asked the question, how do you stop metals that are on fire? Because we were talking about lithium and things like that and all these batteries and stuff we're dealing with nowadays, right?
Yeah. I was thinking about getting my Ryobi batteries out of the house.
And here's the thing. Rachel is a materials chemist. So I think she's around here somewhere. We got to bring her in.
Let's bring her on.
Fly her in. Yeah. Let's get her in.
All right. There is Rachel Kaiser. Rachel, welcome to the show.
Thank you for having me.
So my goal tonight is to try to get the people in the chat to just get a taste of what it's like talking to Rachel. And by the way, Rachel, am I right? You'll be presenting at the symposium this year.
Yes. Yes, I will.
So what are you presenting on this year?
Chemistry of combustion.
Ooh, nice.
Ooh.
So if you're out there, you should definitely, I noticed Brian put out the virtual tickets. If you're not physically going to the symposium, you should definitely, for $26, you should buy that.
Yeah.
If nothing more than to get Rachel's combustion class. It's probably worth way more than $26.
So then if you get the virtual, you could see everybody's class.
Thank you, Mr. Brannaman. We really appreciate that.
The hot topic.
Ty with a witty joke.
Imagine my man with the dad jokes. He always comes through. Always coming through.
I feel like Ty is in all of Ty's spare time. He goes to Books A Million and just looks for dad joke books and just reads them nonstop.
Dude, when does Ty have spare time? Do you see all the stuff he does?
And when's the last time we saw Books A Million? Damn.
Oh, they're common around here, bro.
Yeah, really? People read down here in the Sunshine State.
Oh, hey,
they're all Harbor Freights now.
Speaking of books, this landed on my doorstep.
Oh, yeah.
1 hour ago.
So
I just bought this book. So, Eric, have you read it yet? I just want to give a shout out.
I have not read the second. So this is the second version. I've read the first edition.
This is Don Hollow. Did I say it right? Hollowhan?
Dan Holohan.
Holohan. Okay.
Oh, it's a Houlihan, like Houlihan Auto?
Holohan.
So I don't know his background as well as Paul. You do, Eric. But the man is pretty popular, right? He's the man of steam.
He knows steam like pretty much nobody's business. He's written a lot of steam heating books. And he really has kind of brought back, he's taught classes for a lot of years called the Dead Men Steam School. And one of his big things was learning from the people that came before us, standing on their shoulders and learning from them. And he didn't call it that, because you're trying to, you can die from steam if you screw up, but it's, he did a lot of neat stuff.
You can die from just being stupid,
I've heard the story that the, Empire State Building steam system was refreshed based on some of the knowledge that he brought back. Like they read his book and they were like, "Oh, we can make this work."
We could do a whole episode on Empire State.
That's a different story. We're here to talk about metal.
Yeah.
And that's that's a heavy topic.
Big topic.
Big. Oh man. The dad jokes are just coming tonight.
Rolling them in here, baby. Rolling them in.
All right. Rachel,
Yes.
let's get started. Where
Yeah,
do we start with metals? Let me ask you a question. Do we does this start with the periodic table, or where do we go from here? How do we get into this metal
Yeah, I think
conversation?
the periodic table for me as an inorganic materials chemist by training, the periodic table is the best place to start because um, it's the framework that tells you just by studying it a lot of the properties of the particular elements straight away. That's why they're grouped as they are on the periodic table.
Mhm.
Now,
And I was a slacker and did not make any slides.
do you use that all the time or only periodically?
Coming in not.
Score.
Considering I carry it in my wallet with me just to make sure.
No, are you serious right now? Do you have a little periodic wallet
Yes.
table? Because
Yes.
I can't even pull one up on Google right now. She's got one in the wallet.
All right, here's what I'm gonna say. I'm gonna admit something. I watched some YouTube videos on the periodic table before this show started. Because just to bring myself up to speed a little bit. So that's how so I knew I figured this was gonna go deep and I needed to prepare. I didn't
I
learn
haven't
very
seen
much
one
though.
since
It
I
was
was 18. So
yeah, right. I'm
getting
sitting
flashbacks of that science teacher beat me over the head with a ruler.
oh,
Well,
look.
that's better than in grad school.
There you are.
There we go. Thank you.
There you go. So
Thank you.
There's a periodic table.
Nice.
And we only use it periodically. We don't use it all the time.
That's
Yeah,
true,
all the time.
especially those bottom rows.
Look at the zoom on that. Beautiful.
Okay, why would we not use the bottom rows that
The
much?
two bottom rows are the lanthanides and actinides, and
Oh, yeah.
those are most of them have very, very short lifespans in our typical environment. They don't exist for very long, and several at the very end are basically only been created in labs.
So down here,
Yes, the bottom two rows.
bottom two rows on the which end?
Across the whole bottom. So it
Oh,
starts
okay.
at the pink and then
The
deeper
pinky
pink.
ones.
Yeah,
The
those
pink
are the
and-
lanthanides and actinides.
The pink and the
just to
pinker.
get it
Okay,
straight,
hold on. We
just
got to back
asking
up,
for a
Sam.
friend. Asking for a friend. None of these are hypotheticals, right? These are all found in.
Correct.
Okay.
These
Except
are
what
all
was made in
known.
lab.
These are all the known ones.
Okay.
Rachel, can you repeat those two words?
Lanthanide and actinides.
Lanthanide, actinides, and what does that mean exactly?
So it
So-
sounds like I grew up with them in high school.
So
Um,
lanthanum and actinum.
So they're the start of those. We call them the lanthanides and actinides because it starts those families. So usually the elements are grouped into what we term as families. And because the lanthanides LA is the start of that family, and then the AC is the start of the actinides.
Oh, cool. Okay.
So that works the same way up here as well.
Yes, but once you get to the upper part, most of the families actually go down the groups.
Okay.
So
Yeah, why keep things similar? You know, they got to switch it up on you.
well, we started with the biggest exception. The lanthanides and actinides are the biggest exception.
So basically, if somebody's going to use this, just for the most part, ignore these bottom two rows is what you're saying. Focus on this stuff up here if you really
Correct.
want to work with something.
I got a good question. I think it's going to be good. I don't know. In air conditioning, how could the periodic table benefit somebody, Rachel?
Ooh, that's a good question. I like that question.
It is.
Yeah.
To me, it's going to start, especially where it ties back to what you guys were talking about last week. It's when you're looking at some safety features, the periodic table can be helpful because it kind of goes back to what we're talking about with metals in general. That's a very different fire hazard and therefore a very different safety profile that any technician needs to be aware of. And so the periodic table may help to tell you very quickly, particularly with the metals in the middle of the chart, whether you have something that you're going to have to use a different fire extinguisher if you are caught in a situation. Now you're not going to pull out a periodic table then, though, is usually the challenge that I would see with that.
That's a good point.
Because it's already on fire. Um,
This is why, and this is why you carry. This is why you carry around one in your wallet. So if you know what the metal is, you can just whip that out and be like, "Oh crap!
Yeah,
I got to use a different fire extinguisher."
I mean,
Sounds
an
like we need
example was my uncle actually worked in a factory, and they worked a lot with metals, and they added a process that utilized zirconium. Zirconium is one of the key metals that I did a lot of research with. Titanium and zirconium were the two
You want that chart
metals.
back?
That's not.
Oh yeah.
For
Oh
sure.
yeah.
We need the chart. Yeah.
Now, are you talking about cubic zirconiums? Just throw diamonds on it?
No, just zirconium, the metal.
Just zirconium. Yep.
Zirconium, the metal, is very, very flammable, and can actually spontaneously combust when compressed. So it's
Here, pull up that table.
Yeah, give me that.
I gotta know how she knows this.
I gotta be
from the
grounded.
table. Like, I don't even know where I'm going. Like, is that on the? Does flammability exist to the right, left, down, up? How do we know that?
Yeah.
You look at number 22 is titanium.
So there's titanium.
Okay.
Number 40 is zirconium right below it.
Okay.
And that's why. So what you do, and then you have hafnium, and so in that family, 22, 40, 72, 104.
The yellow family.
Well, the yellow family across there are your transition metals. That's the transition part's not the important piece. What you have is you have similar valence levels when you go down in the groups, i.e. what that means is you're looking at a scenario in which you have a given number of protons and electrons on each metal. So that's the 22, that's how many there are, or 40. Those tell you how many they have. So what you're looking at is when you get to the metals, you have a situation in which you have a lot of those electrons free and available to do a lot more reactions.
Oh, wow.
So like in that case, they're able to, so metals tend to be larger atoms, and then they spread the electrons around, and they have them in their what we on the chemistry side call their shells. So they have different levels where their electrons and their charges are stored. So you have more of those shells the larger the molecule, the larger the atom is. So it also works the same when you have molecules.
So how would we figure out, like, how would somebody use this table to figure out what is flammable? What would on that table would tell them something's more flammable or less flammable?
Unfortunately, from flammability, it's not as clear cut as reactivity.
Oh, right.
Because
what about reactivity? You're saying that's more reactive to like other things that might be in normal environment,
like the atmosphere, just like opening something up.
That can be, and then you also have situations where so as a chemist, what it usually does is it quickly tells you how many free electrons, i.e. how much negative charge you have available to build molecules with. So that's not going to be, again, that's not a useful component to a technician because you're not trying to build out what is the reaction happening. Those are the cases. This is where that's in the weeds, and it's a lot of what can these different atoms do. That's the safety piece, that's the take home. So perhaps the biggest part is that the periodic table is not going to be a super useful tool to a technician to know.
What's the number at the bottom? Is that the weight?
Yes, that is the weight.
So copper is heavier than iron. That's crazy.
But that's is that like weight per volume?
That's per atom.
Per atom.
Damn.
Okay, so that's the atomic weight.
That's the atomic weight.
Yep.
So I used to one of my one of the things I have done previously as a job is actually weigh atoms and molecules. So those were very important, knowing
That's
what those
some
are.
light lifting right there.
It is.
You
But
pick those up with a set of tweezers.
Yeah.
yeah, that's exactly what it is. Or you actually use my favorite is to utilize lasers.
Where's aluminum on here? Because that's where
So
all the
aluminum,
coils are.
you need to go. Yes, I was like
over
to the
here.
right.
The scrap pile. Okay. All right.
So
It's over here towards blue, for beer can cold.
Yeah, for beer
that is
can.
correct.
So I guess I kind of probably already know the answer to this question, but when we scrap out air conditioning units, the copper is the value, and the aluminum, I'm assuming, it's not worth anything because they want pure copper when they can get it. What makes it so valuable? Is it just the repurpose capability of it, and the aluminum's not very well repurposable like the copper is?
That's a very economic component as far as that. When you it's the periodic table itself doesn't help tell us what the value in our society is.
Yeah, I didn't know if aluminum was difficult to recycle, and if anything on here was like pointing towards its difficult capability of recycling.
It's not per se difficult to recycle. It's not like a polymer or things like that. But a lot of times what you get is I know that aluminum tends to oxidize in a lot of these scenarios, and then separating that is far more problematic.
Okay. That's what I was saying in the last show, that I seen a guy take mercury, put it on a sheet of aluminum. It was thick though, and it was just like made it like grow like it was like a fungus. It was crazy.
Okay, we got a quick question here
That's
Okay.
not fake news, is it?
from Mr. Hausch.
What are the weights in the brackets?
So like he's talking about like down here
Oh,
on the on the bottom, like let me see if I can get this to zoom in.
Yeah.
Down here on those brackets.
that's because those are approximate. They don't have getting those to ionize to be able to get an exact mass. That's as close as they've gotten.
Hey, Hausch, we're working on tweezers small enough to grab those atoms.
I never knew that there was some stuff unknown. That's the
There's
first
a
time
lot
I've ever
of
noticed
unknowns.
that. Wow, we got a lot of work to do. We
And
don't
it
know
all
everything.
comes down to when you look at these, there's not a lot, or they don't exist for very long.
I got a question for you, Rachel. This goes straight to HVAC. I've read somewhere or heard it, I'm not sure, but like you said, aluminum oxidizes.
Yeah.
I know copper oxidizes and aluminum oxidizes, but I thought when aluminum oxidizes, it creates like a shield. And this, I'm just trying to bring everybody up to speed of why this matters. We all deal with leaking coils, right? And so everybody thought the industry went all aluminum over weight, and maybe they did. But I've also been told that maybe we went to aluminum for the oxidation reasons, because copper will oxidize and then continue to oxidize. But then I've heard aluminum oxidizes. Yeah. But then aluminum will oxidize. And I've heard when it oxidizes, it stops because it creates like its own barrier from the oxidation. Is that not true? Did I receive that message wrong?
Is this fake news?
So
Yeah.
aluminum does oxidize very differently than the transition metals. So you are in a situation in which it will behave very differently than the copper when it comes to that. So yes. But there's also a lot that the aluminum, like when you expose the aluminum to a number of the refrigerants that, I mean, Eric, you had one of these instances where it was phonochemist, where the aluminum becomes one of the reaction spaces that when you open refrigerant and some air, With the aluminum is actually more reactive than copper is
So
in a
pull
lot
a
of those
vacuum, you're saying.
situations. So you end up where there's a couple of the refrigerants and aluminum can actually react within the air to make some really terrible acids that would be really dangerous to a technician.
Oops, sorry.
So you're saying that if someone doesn't pull a really good vacuum on an a system with aluminum in it, and there's air in the system, they're really going to get a nasty acid in that air conditioning system.
You can, depending on the refrigerant. It all is dependent on what refrigerant you're using.
Yeah, what the makeup of that refrigerant is, and that's the thing. Like, there's all, and this comes back from some of the questions I've asked Rachel over the years, being in the field, as she calls it, phonochemist, which is something that I used not infrequently. When I would see different things and we would talk through some different stuff, because I wanted to learn more, and I had the access to that. Like, when you start talking about stacking different stuff up, I don't know about, I mean, maybe Ty, but maybe I don't, that's a whole different ball game here, perhaps. But you start stacking different things on top, different chemicals on top of each other. And unless somebody actually goes in and stacks not only all those same chemicals together, but in the same concentration that you're doing it in the field, the reaction is completely unknown.
Yeah.
Right. So that's where, like, she and I had a lot of conversations about coil cleaners, right? Because one of the things we do as technicians is, man, that's a really dirty coil. I got to put more cleaner on that, right?
Yeah, for
Put a
sure.
little acid on there, right?
I want to see it just boil out. I mean, when I was younger, I loved watching it just expand and boil out. Now looking back, I'm like, man, I did some major damage to coils.
It's a 2-for-1, bro. You clean a coil and your nose hairs are all gone too. So
that's right. And like, all the leg hair is gone because they just eat right through your pants.
Sometimes if you put really concentrated coil cleaner on there, it doesn't work as well as when you mix it.
I noticed that. You're right, dude. You nailed it. I did that one time and it was just like, did nothing.
Right. Because when they design it, when the chemists design it in the laboratory, they design it to work with that water.
Gotcha. Yep. Yeah. I remember, what's his name? What's the Italian guy at the Viper?
John Pastorello.
Pastorello. He was saying that also, if you got, like, let's say you go to a house all the way in the boonies and they got well water and it's super, like, heavy with a lot of calcium and stuff like that, it's not going to be as good as a softer water too, kind of like what you're saying. You add a lot of minerals in there and it kind of, it won't get that sudsiness, right?
What you get a lot is iron in well water, and iron actually binds up a lot of surfactant compounds very quickly. It also it's actually the iron in well water that doesn't allow things like Roundup to work. If you actually mix well water that has iron in it, you won't get Roundup to work.
That's correct.
It binds up the active components and doesn't allow it to.
There's so much iron in my buddy's well water that his toilet's orange.
Man, I'm living that life, and all I'm thinking about is how much money I've spent on Roundup. Now it's like I just got hit with a double whammy. One, I'm over here like taking the concentrated bottle and I double down because I'm thinking I'm going to kill some damn weeds, right? Like I don't want to touch this for like 6 months.
Yeah. 500 square foot per ton.
That's right. Boom, boom. Here we go. I don't want a weed in my ditch.
But it doesn't work.
It doesn't work.
It doesn't work. That's crazy.
I've noticed it. Well, here it has worked, but here's what I'll tell you.
It doesn't work as well.
If it rains, it definitely doesn't work. But like if it's when it's dry, and I soak that ditch down, everything dies. I mean, if there was a little baby deer in there, I think I'd kill it. You know what I'm saying? Like It'd kill everything.
Why
But
you
I'd
gotta
still
go
kill-
there?
Here
I'm
comes
just
PETA.
saying, it'd kill anything.
So,
You know?
so I mean, going back to like let's go back to HVAC chemicals rather than Roundup, but
We should do that. We should do that.
It's kind of the same thing. You know, if you put that well water in versus like say, I don't want to say RO water, but like deionized water, right? You get deionized water from a store and you get bottles of deionized water and you mix that with your chemical. Is that going to work better or worse?
It'll work better. You don't have any additional ions to interfere with the way that the chemical was designed to work for your cleaning or anything like that.
Are you talking about like distilled water, Eric, from
Yeah.
the grocery store?
Yes.
Yeah,
Distilled, deionized, there's a whole lot of levels of water.
See, this was one of the things that I learned from Rachel that never really clicked with me. What we call water, that technically water is considered H2O, right? That's
Correct.
what we know it as. It's H2, which is 2 hydrogens and an oxygen. But the water that we get out of the tap or out of the faucet, whatever, ditch water, ditch water.
I drink ditch water. That's what I like the most.
So
they all have a lot of added elements and that in it. It's not H2O.
It's not pure H2O. It's a solution of water. You know,
That's
H2O
right.
is the primary piece, but there's a ton of other stuff in there.
See, whenever they have those commercials, you know, and my wife's like, we should get the Kentwood guy and have him come over here and deliver something. And I'm like, no, I want my water coming from the ditch, right? I want it slab full of minerals. I want to know, like, I want to be drinking, you know, dead dinosaurs and stuff.
You're drinking that ditch water with the Roundup in it, right?
That's right. I want immunities, man. You know, I want if somebody sprayed me in the face with Roundup, I'd just be like, let's go. Right? Superman.
I don't think that quite how that works. I think there may be a slight flaw.
I don't know.
His
body's resilient. That's all I'm saying.
So what about heat transfer for like aluminum coils versus copper coils? What are we looking at for there?
I don't know that off the top of my head. I didn't work with either of those, but I know like copper from a diffusion barrier for semiconductors, because copper was what had been historically used for a long time. And the point is you can only get copper to be so thin and still have barrier properties, whereas you can use a much thinner layer of something like titanium and zirconium to actually do the same barrier properties. And so that's what, for me, it's taking and looking at the periodic table is what else can do that. But then when you look at HVAC, it's about not only can it do it, but is it feasible to be manufactured?
Right. Yeah.
So it doesn't, I mean, titanium's very expensive.
So I got a question here. When you say barrier properties, what do you mean by barrier properties? Are we talking about, because we think about, you know, barrier properties like, okay, it'll let a fluid through or it'll let a gas through.
This is about letting charge through.
Okay, so like charge, so like charge different charges of molecules, right?
Yeah, so at that point you're looking at a positive or negative charge. It's the same as electricity, but here we're at the atomic level and shuttling that charge either across or through the different materials.
So is that something that like we would be concerned about with refrigerant going through copper or anything like that? Or?
Not in the time frame, because you're looking at multi-layered. What I was talking about is at atomic levels. So we're talking about being able to put one layer of an molecule down on a substrate. In the semiconductor industry, HVAC works on a very different macro scale in comparison.
Okay. All right. I just wanted to make sure I had my head wrapped around that correctly. See, these are the questions I have to ask to make sure I get my head wrapped around this. These are nightly conversations, folks. Like, this is every day.
Hey, Eric, dude, keep up, okay?
So like this is actually an example of a titanium molecule that I made that you put as a single layer on as a diffusion barrier for semiconductor research. So this is a single, you put one atom down, whereas copper has to have multiple to get the same properties. Again, that's a super micro scale in comparison to what we would talk about for HVAC.
Gotcha. I got a question about the copper coils. One more. We had Fallon was on. We were talking about the slime and the coils and everything, and she was saying that copper was giving off a bit of what was it again, Eric? It was copper ion when passed through air and water. So the water was given a little bit of an ion, and the aluminum coils, we're not seeing any type of ionization. Have you heard anything like that? Because we've been seeing so much problems with the condensate drain lines.
So what the theory is that the copper basically ionizes the water in a certain way as it drains away, and that keeps the slime from growing in the drain lines. Is that what you're saying?
That's what, yeah.
Or that's what the theory.
From what we were hearing, yeah.
Because there's a lot of there's companies out there now that make I think Diversitech has it. It's like a copper infused, essentially like a snake, or it's like a rope that you actually lay in the drain line, or you pull through the drain line, and that's supposed to keep the slime from in there. I don't know, Rachel, can you explain that a little bit?
Yeah.
So I just know, again, I don't know a lot the details about copper. I would have to do some research, and I didn't come in prepared on that topic.
Yeah, no problem.
But copper is known to have a very different ionization and is often seen as sort of cleaning things fairly well.
Okay.
So it has some of the properties that have often been used, even like in medicine and things like that, because of what it's able to do. So without looking further into the research, I can't give any more deep dive on that. As far as the surface and what they're using, because when you look at these, it's usually not a case of just a given element. They're often alloys, and I don't know what they use.
Yeah.
So without that kind of information, I can't answer your question.
Yeah, copper has all kinds of weird stuff. You see like products like around COVID that had like these little spandex like gloves with copper infused in them. I'm like, come on now. Like, this is getting crazy.
Hey, bro, don't be hating on my Brett Favre socks now.
Oh.
You know what I'm saying?
Right.
And my bracelet. That's going to add 20 years.
Oh, the copper bracelet. That's right. Yeah. That's right.
It's 20 more years.
With the magnets on it, baby.
Make it to 100.
I want to go back to our original question that we ended the show with last week about fires and metals fires specifically. Yeah.
Fire it up, Eric.
And what it takes to put those out. Because that was a question that you asked last week, Chris, and I said, that's what we're bringing Rachel on here for, is to talk about this. What in the world?
What in the funk is that?
Rachel, this is my model.
Oh.
Yeah.
What is that? Looks the COVID-19 virus?
It looks Legos, man. It's my Lego model. Built with my kids. I'm just saying.
Octopus on top of a tree.
I just want to let people know I got my model. Rachel's got her model. And these yahoos, they don't have any model.
Okay, I got it. I missed it. I'm sorry.
All right. Sorry. Keep going.
Yeah.
So let's go to metal fires.
Metal fires. And essentially what you're looking at in that situation is it's called a Class D fire. And that's really important to know, because when you go around, if you're a technician, most places are not going to have Class D fire extinguishers. And unfortunately, lithium is a Class D fire source. So when you look at what the class, most of the fire extinguishers you're going to run into in buildings where you're working are the red ones. And those red fire extinguishers are either usually Class A or Class ABCs.
Oh wow.
Most fires are ABC. Most fire extinguishers now are ABC.
So that's a no bueno.
So what you're looking at is, in those cases, all those red fire extinguishers that people put in their work trucks that they have, around buildings when you're walking through, none of those are going to help you put out a Class D fire, i.e. any metal fire. And Class D involves any combustible metals. So magnesium, you know how they sell at the stores, they'll have the magnesium fire starters.
Yeah.
Yes, that's a combustible metal. Your
Wow.
titanium,
Yeah.
your potassium, your sodium. I'm sure many of you have seen videos where people throw a big chunk of sodium into a water pond or anything.
Oh, I watched that dude throw it in the pool of his backyard in Florida here.
There we go.
Florida,
Don't
man.
do that.
Especially with chlorine in there, right?
There you are. Thank you. So what you're
fire
looking at,
fire classifications, right? Either fire extinguisher classifications.
yes, which then boils
All I
right
hear
back.
is Beavis and Butthead. That's all I hear right now. Fire.
Which is great, from the sense that we do have to proactively think about these.
Wow.
And you're looking at, with a Class D, your aluminum, your magnesium. So if you're talking about whether, there's been a lot of discussion on like A2Ls and the flammability of the new refrigerants in comparison, you're already working with a lot of very flammable
Yeah, I got like 10
metal.
battery packs of like what is it? What's in those things? Lithium? Lithium ions.
Yes.
Yeah.
And
I'm rolling around with like 20 pounds of lithium and acetylene in the back of my truck. And these jamokes are worried about it like a A2L, you know?
And that's a Class D fire with the lithium, which the extinguishers that we carry on our trucks are typically ABC extinguishers.
So it will not work. Class D fire extinguishers, there's typically 3 options in the Class D fire extinguisher.
Like baking soda?
Sodium chloride is a very typical one. So that's just salt.
Salt.
Yep. Sodium chloride is just your usual table salt.
So when you wear that drill out and it catches on fire, man, just
salt it up. A little salt and pepper on there.
So the U.S. Navy actually developed a copper powder that they use for lithium fires in particular.
Wow.
And then there's also graphite. Now you have to be
that is blowing
very
my mind.
careful in all these cases, because what happens when you have a metal fire is you're looking at a situation in which not only do you probably not have the appropriate kind of fire extinguisher, but you are looking at a fire that will burn much, much hotter than your typical ABC kinds of flame sources. And they do not go out so easily. They're actually a chain reaction fire. And so, like, what happens if you use graphite is it actually goes molten, and that's what stops the chain reaction in these situations, because you have the metals are
so I'm gonna
burning
get
at
these lithium ion batteries out of my house tonight. So
I'm
gonna have to leave early.
So that's where you have to be looking at how to control these combustible metal fires in a very different way than you would have usually come in. Because, for instance, if you have a metal fire, you have to, you want to be letting, fire services or anyone of the response team know that there's a metal involved, because actually pouring a lot of water on them can make them worse depending on what the metal is that's burning.
Yeah.
Right.
Now, I did just read here that I was pulling up trying to find the temperature of lithium that burns. The lithium ion batteries are actually considered a lot of times a class B fire.
Okay.
Because they have liquid electrolytes in them.
Yeah, which changes the parameter. You're not just looking at a solid metal.
You're not looking at straight up lithium in there because they've got different. Again, that's where stacking different chemicals, right? That changes things.
Just knowing that you have one of those elements, it's the same question, kind of, tying to what you'd asked before on, and I said I don't know which alloy they're using. So it depends on what kind of situation these metals are involved in. If it's just the metal on its own, how they have to be dealt with is different than if they're in often solutions or as alloys and things like that.
And the battery thing is HVAC related because I'm talking to my buddy and he sent me to go do an estimate for a house, and it was a structure fire, and I was like, what happened here? He's like, well, one of those scooters that when you pull up YouTube, you watch people fall on their ass on the scooters, those little the two-wheelers.
Yeah.
What are those things called? I watch all day. I watched that for like 20 minutes straight, people getting on that thing. Whoop, whoop. So that thing just, I guess the charger overcharged, or they were having problems with the software on the charger, just burnt that house down.
Well, I mean, like we were talking about last week, you get that. So just looking here, I'm doing some quick research while we're talking.
Segue, Michael House to the rescue.
So because lithium ion batteries don't actually contain metallic lithium, right? They contain lithium ions, hence the name. So the class D is not going to be effective on those because of the type of the powder that it uses. But that's where we were talking about, like that battery, if the batteries rupture and the heat cycle in those batteries causes that battery to rupture.
Yeah.
Then it gets hot enough that it starts the components inside on fire.
Yeah, it was crazy. I was watching that video. The guy was taking out that cell phone battery apart, and that thing was just lighting up as he's moving it. It's some wild stuff.
I'm sure you guys have heard this, but did you know, I didn't learn this till after running through a few sets of batteries, that those lithium ion batteries, they say you're supposed to let them cool down completely and then put them on the charger. You don't run them hot and then throw them on the charger. They say it's a no-no, and it destroys the battery life.
Well, if you look at, like a lot of the chargers or a lot of those batteries actually have temperature sensors in them.
Yeah, man.
Mm-hmm.
And if you plug them into that charger and they are too hot, that charger's not going to charge them.
Yep.
Oh, yeah, true. Maybe I got some old sets before they figured it. I don't know.
My son uses the Ryobi for the weed whacker, and dude, when it's like 100 degrees out there, man, that battery goes quick, and when you put it on a charger and it's smoking hot, it will not charge it. Thank God, man, because I don't have that much salt around the house.
Yeah,
put that sucker out,
But the thing is, like a class, they're saying lithium, the lithium ion batteries are a class B fire.
Well, they are B. Okay.
Okay, so that's what they're saying here. They're a class B fire.
Okay.
Because they've got liquids in there.
So my kitchen one will be able to put it out.
What do you not use on a class B fire?
That's a good question.
I don't know.
Because a class B fire typically involves liquids, right? So you don't put water on it.
Makes sense. Don't put water on a battery, right? Yeah.
Well, I mean, it's not going to work for a class B fire, which is why we get, we get a lot of these lithium battery fires in cars or even in houses or in the batteries. Don't throw water on them because that's not going to help.
Right.
I want to pick Rachel's brain. I want to see if Rachel will give us a sneak peek of what she's talking about come the symposium.
You
Well,
don't let
good
the cat
news
out the
was
bag.
actually talking about things catching on fire. So
Yeah.
I've already been there.
Come on, Rachel. Sneak peek. Here we go. Lay it
It's
on us.
basically diving into what's happening from a chemistry standpoint when we have the combustion that we usually run into from like a piece of equipment that is intended to operate based on combustion. So the focus is going to be on that and kind of dispelling some of the aspects of, oh, if it looks a certain way, then it's got to be operating as we expected, things like that, because it's going to be not only looking at what's the actual chemistry happening behind that combustion, but how different environmental factors can significantly change the chemistry that's happening around that combustion, and what that can do to the safety of both the technician working on it as well as the homeowners.
Nice. Have you ever, do you plan on going down the rabbit hole of looking at altitude in this situation as a factor? Because I've been doing a little bit of research on that from my end, and I've got, OEM literature that speaks on deration as you get into, higher altitude. But I also have an ASHRAE document that I haven't started reading yet, but I'm about to start reading it, that basically is kind of debunking the whole factor of deration as you climb in altitude. But I haven't read it yet. But
Gotcha.
it's exists.
I mean, that boils down to essentially the same. What we are looking at is what's the environment that you're having this controlled fire take place in, and what are the elements or molecules that fire is being exposed to. So if you look at changing elevation, what you're doing is typically changing how much oxygen is in a given space. So that's where you're going to be looking at what does that push and how real is that, on how that can change your combustion.
Can't argue with that.
Basically, it boils down to when you go up in altitude, right? A cubic foot of air has fewer oxygen molecules, fewer molecules. Period.
I have another question.
Get less molecules on the Himalayas.
So you know how people say the air gets thinner as you get higher, and my take is air. I don't like to say thinner because I think it sends the wrong message. It's just less air per cubic foot, right?
Is it less air or is it less oxygen?
Fewer molecules in the total cubic foot.
Yep.
Right.
Okay.
So it's in effect thinner because if you counted all the molecules in that cubic foot, they're not compressed as much because your atmospheric pressure is lower.
In the exact same volume, you have less of an amount of air in the same volume at a higher altitude than you do at a lower one.
Relate that to kind of like relative humidity works. The sponge, as you go up in altitude, the sponge can't hold as much.
Question is, though, I'm trying to wrap my head around this. Is anything else filling in the void space?
Dark matter. Yes.
Or like, I guess I have a mind block. So like, you have air in a box, and then as it goes up, the air expands, and if you were to slice it, this was the original box. But is that how it works, or is there other molecules that's in that box that are not air at that time when it went up? Am I making that clear? Or is that really not coming through very clear?
It's basically the distance between the molecules, as I understand it. Am I saying that right, Rachel?
Yes.
So the distance between the molecules gets farther apart as you have less pressure pushing in on it. It's kind of like taking that cubic foot of air, right, at because if you look at atmospheric pressure, you have to look at absolute pressure.
Mm-hmm.
Right?
Can I take a squeeze at this one, Eric?
Yeah, go for it.
It would be like the same volume, like in a compressor, right? In the compressor head versus the suction line. So one's compressed, right? So you're like at sea level, right? Inside the in like what? Let's use a combustion engine, right? Inside that, when that stroke is at top dead, right? And then when you have it when the stroke goes down, I mean, you get the same amount of molecules, but it's just
in a smaller volume. Yeah. So when you take that same, if you're running that same, say 10 CFM of air through that furnace, we'll say 15 CFM of air. But if you're running that same 15 CFM of air, the air at sea level weighs more because there's more molecules in there.
Mm-hmm.
Versus the air at, say, a mile high in Denver weighs less per cubic foot because there's fewer molecules in that cubic foot. This goes back to one of the things where I think Jim Bergman said it first, really, is the one that I heard say it, is that we would be better off measuring pounds of air going through a system rather than cubic feet of air.
Mm-hmm. Yeah. I believe that's a Jim Bergman
quote.
Quote.
Because the pounds of air actually tells us how many molecules are in there versus.
No, that ties right in with SCFM.
Yeah. There you go.
You should understand this. Of all people, you should understand.
I do understand it. It makes me also think about water. You know what I'm saying? Like, as I relate that to like water in a swimming pool, and water at the bottom of the pool, and you have water on top of the pool. People will use the swimming pool analogy for this a lot, but I don't think it jives. But I don't know. That's why Rachel's here, and I'm going to ask. So, like, if you have water at the bottom of the pool, there's not going to be more molecules of water in 1 cubic foot as on the top of the pool, right? Because the water, if I'm not mistaken, it's not spongy like the atmosphere.
It's not lighter at the top. Yeah.
Right. It's not, water's not lighter at the top of the pool.
But we're talking sea level, the Himalayas.
You've just switched from talking about a gas versus talking about a liquid.
Yeah.
And
right.
so you've
I'm just trying to bust
similarities, but there's also significant differences because the way the liquids behave versus how gases behave is not.
If you want to see something really trippy, is where you go and see salt at the bottom of the ocean. It settles lower than different layers of the, blows your mind away. Google that when we get off.
So, and I'm going to say, Chris, that the differential between the water at the surface of a pool, at the bottom of the pool, is, you can't measure that, basically, right? Because water is, it is in theory not compressible, but it actually is compressible.
Right.
Right. But if you take that to, say, 1,000 foot of difference in the ocean, then you've got enough differential where, yeah, you're probably going to have some molecular concentration differences between the bottom and the top of that range.
And what's the elevation of like Colorado or something? Is it like 2 miles up? Like, what are we looking at compared to sea level?
Well, in Denver, it's
probably like 10,000 feet.
Denver's mile high.
That's a lot of feet.
5,200 ish.
Dude, yeah, that's pretty big. Shazam.
Yeah.
Well, this whole state over here is like flat. It's like, Badlands over here.
Is it specific? Oh man, I'm drawing a blank right tonight. Specific what of air? I know standard air is 0.075, and I think Colorado is 0.062.
Yeah, I don't remember. So here I found out water. Compressibility of water at room temperature is 0.00053 for an increase of 1 atmosphere.
Thank you, Michael. I was talking about specific heat of air. Specific heat of air. Sorry. All right. Well, my mind's blown. I need to go read a book.
I'm gonna go watch this 3 times.
Yeah. Rachel, would you like to leave the crowd with any takeaways? Let them have it.
Just remember to come join all of us and learn some more about combustion at the symposium in
Totally agree with that.
January/February.
Yes, indeed. We will see you there.
Don't forget to comb your hair.